Okay, we want to talk about how column matrices can be represented as vectors in Euclidean spaces. Okay, well, the column vector 5, 3 can be represented in R2, which is two-dimensional real space, a real axis this way, a real axis this way, traditionally labeled x and y axes. Okay, this is going to be represented in R3. It's going to be represented by an arrow. Okay, first of all, 5. Okay, this is going to be the x-coordinate, this is going to be the y-coordinate. So x is going to be 5. So let's see, x is 5 here, and y is going to be 3. So let's say y equals 3 is about here. Then we can, of course, find the point point 5, 3, going to be right here. The vector we're going to think of as an arrow. Generally rooted at the origin, although there are cases where we want to get arrows between arrows and you can't put them all at the origin. But we consider the vector to be, unless otherwise dictated or specified, as being rooted at the origin, so that its terminal point, the head of the arrow, is at the point 5, 3. So this is the arrow that represents I'll label that as the arrow representing the column vector 5, 3. I'll note that the vector has a length, which we call the magnitude, by the Pythagorean Theorem. And this is something I assume everybody's quite familiar with by now. Length or magnitude is square root of 5 squared plus 3 squared, because you have this right triangle with legs 5 and 3. Now, if you're not really familiar with the Pythagorean Theorem to the extent that this is totally obvious to you, you want to get a little more familiar with it. Okay, so the length or magnitude of that vector is this sum. And the angle with the positive x-axis is the inverse tangent of 3 over 5. Now again, if you haven't done trigonometry in a while, you might have to review it a little bit, but please do, because we have to assume that you understand basic high school mathematics or pre-calculus mathematics. Okay, so this angle is the inverse tangent of 3 over 5, can be calculated in radians, can be calculated in degrees, or in other measures of angles. Very simply using your calculator. There's a little more to determining these angles, because there are actually two angles that have the same tangent. Not going to get into that right now. Okay, just referring to the fact that you need to understand basic triangle trigonometry. And just pretty much just right triangle trigonometry. There's one application of the law of cosines in linear algebra. So the trigonometry doesn't get too complicated here. But right angle trigonometry is often important. Okay. Now, another example, the vector negative 3, 4, 2 can be represented as an arrow in R3. Well, negative 3 is going to be the x component. So x is negative 3. Well, let's just say units are about this big. negative 1, negative 2, negative 3. So here's your x component, negative 3. The y component is 4. And at this point we can locate the point negative 3, 4 in the xy plane. We simply move parallel to the y-axis, which doesn't change the x-coordinate, until we get out to a point on this line. Well, okay, we move out along the line in the xy plane where x equals negative 3, and we move along the line in the xy plane where y equals 4. So let's see, y equals 4, and of course the x-axis is represented here in this direction, so we've got to move in this direction, in the x direction, until we meet this line. Now we'll extend these lines a little bit more to show that, well, sometimes you've got to draw them. Better to draw them too long than too short, so that they're assured of intersecting. Okay, so now we have this point. And this point, of course, has a z-coordinate of 0 because it's down in the xy plane, and z is 0 in the xy plane. But we do have this point now negative 3, 4, 0. Well, now we need a z-coordinate of 2. Well, okay, we can do that. Here's z equals 1, here's z equals 2. Okay. So to have z equals 2, well, the plane where z equals 2 lies 2 units above the xy plane. So we got to come up 2 units here. So 2 units is this far. So let's just take that distance and move it over to here. So here's 1, 2 units in the z direction, and here's our point. And this point will be negative 3, 4, 2. And then our vector is going to be rooted at the origin, and it's going to come out to this point. Now that might be clear enough. This might show you clearly enough where this vector is. It goes back from the y-axis and up, so it's kind of in this direction. We can improve the sketch maybe a little bit by sketching a similar vertical line here, and I kind of made it too big. Okay, it should only come up to about here. And connecting a few of these points in a vertical here, and a line here, and it didn't come out real good. Not a great picture. But we kind of got this box, and if I'd have done that more carefully, it would be a little more like a box. And we see that this vector goes from the origin out to this opposite diagonal of the this point that's diagonally opposite at the corner of that box. Okay, looks like my distance here, yeah, came up too high there. Anyhow, we get the idea. Here's the vector. Let's go ahead and give it some color. So there's the vector representing negative 3, 4, 2.